Hi, today I want to use my linear algebra with complex value to study current circuit. This is an example of current circuit. I have drawn here the current circuit. To study this current circuit, I have decided to use the Kirchhoff current law. This law says the sum of the current flowing into any node, the sum of the current flowing into any node is equal to the sum of the current flow flowing out. The sum of the current flow flowing out. For example, for the node A, in this example, the node A here, the node A here, the input is I1 and I2. I1 and I2, and the output is I3. The output is I3. Okay. I have write the first equation for the node A. Now the node B. The input for the node B is I3, and the output for the node B is I1 and I2. I1, I2. I have two equations, one for the node A, and one for the node B. If I can remark these two equations are equal, so I have only an equation for the node A and B. This is the equation. I have noticed this equation A. This is for the Kirchhoff current law. The sum of the current flowing into any node is equal to the sum of the currents flowing out. This is the Kirchhoff law. Now I want to use the Kirchhoff voltage law. In one traversal of any closed loop. You have in this circuit three closed loop. This is the first closed loop. This is the second closed loop. And this is the third closed loop. Alors, Kirchhoff voltage law, in one traversal of any closed loop, the sum of the voltage rise equal the sum of the voltage drop. The sum of the voltage right equal the sum of the voltage drop. I have chosen a direction for this loop. The first loop is the left loop. I have chosen a direction for this loop. This is a direction. Alors, this is the left part of the circuit. You have the result is the voltage V2, and this is the voltage V1. Okay. Alors, why the voltage V2 is positive? Why? You can see the direction of my loop, is opposite of the direction of the current for V2. For V2 is opposite. Also, you must write this voltage arise. Also, you must write with the plus sign. This is the voltage V1. You have a sign minus. Why? Because the voltage drop. The voltage V1 drop. Why? Because the direction of my loop is the same as the direction of the current. Also the voltage drop, and you have a minus sign. In this case, the voltage and the direction of the loop and the direction of the current is the same. I must write a minus sign. With V2, the direction of my loop and the direction of the current is opposite. Also, I must write plus. Alors, this is my second equation. I have only write I1 in first and I2 in second. This is the second equation, the B equation. Now I want to work with the right part of the circuit. This is the right part of the circuit. I have chosen the same direction for the loop. You can see here this voltage V2 and V3, V2 and V3 are drop, the voltage drop. Why? Because you can see the direction of the loop is the same as the direction for the current for V2, and the direction of the loop and the direction of the current is the same for V3. So I must put the sign minus for V2 and V3. This is for the resistor. For the generator, you must, when the current come into by the left and get in by the left, get in by the minus sign and get out by the plus sign, this voltage is drop. The voltage drop. So I have here the plus sign. This is the second equation. You can do the same thing, the same thing, well, with the external part of the circuit. The external part of the circuit, and you can do the same work. You have the same direction for the loop, and you can write this equation for this loop. Now you have four equations. You have four equations and three unknown. You have four equations, 1, 2, 3, 4, and three unknown, I1, I2, and I3. You can give the value for the resistor. Why? Because on the graph you have the value of the resistor. You have the value of the resistor. Then you can write this equation in this way. Now you can write the system in this way. The first column is for I1, the second column is for I2, the first column is for I3. Now I have right here the linear system in C language. I have added a zero column. Why? Because I have 1, 2, 3, 4 lines and 1, 2, 3 column. Also I have added a column. In this manner I have 4 lines and 4 columns. It is better for my function that I want the Gaussian function. Now I want to resolve this system. Also I use the C language, the C file for this work. I copy the C code for my linear algebra that I have made. This code is for real coefficient, but I want to work with complex coefficient. Also I have added imaginary part of this number, the imaginary part. Now I use a Gaussian to resolve this system. Alors, I have A, I have B, I have the system AB with the column of 0, and with this is for I1, this column is for I2, and this column is for I3. You have the code here to resolve this system with octave. Oh, sorry. I copy this system in octave. And this is a result with octave, and this is a result with math function. You have the same result. Instead of use the Gauss-Jordan function, you can use the QR factorization, I copy the code into my editor. Alors, this is the QR decomposition with octave. Sorry. Up. Alors, this is my QR decomposition with octave. It is the same value. You have Q, comment ça s'appelle? The Q matrix and R matrix. You see the matrix R at triangular. Also, it is easy to inverse this matrix. Now I take the conjugate transpose of Q and the inverse of R. Why? Because R is easy to inverse because it's triangular. And now I use the algorithm for the QR factorization to resolve a system of linear algebra. You multiply B by Q, the conjugate transpose of Q and the inverse of R, and you have the result. You can see in this example I have not added a column of 0 with QR factorization. Is not a good idea to add a column of 0, and you have the same result 1, 2, 3. 1, 2, 3. You can verify the result with a Gauss-Jordan function. 1, 2, 3. But in this case, you have a column of 0, and the result gives a line of 0. With the QR factorization, you have not the column of 0 and the line of 0. You have another method, another function. This is X value decomposition. X value decomposition. Sorry, I have I copy the side. Sorry. Alors, the code. Alors, you have the function QR factorization. You put A and Q and R. You take the conjugate transpose of Q. You take the inverse of R. And now you multiply inverse of R by conjugate transpose of Q, the inverse of R, conjugate transpose of U, and then you multiply this result by B, and you have the result you have the result 1, 2, 3. Now I want to work with the X value decomposition. Alors, I have copied this. I copy this code into my editor. In the same way, you have A, you have B, you compute U of the X value decomposition, you compute V of the X value decomposition. Now you take you conjugate transpose multiply by A multiply by V, give a diagonal matrix. You can easily inverse a diagonal matrix, and now you can create the pseudo-inverse matrix for the matrix A. Here you have the diagonal matrix that you have inverse. You multiply by the left by V, and by the right by the conjugate transpose of U, and this gives the pseudo-inverse. And now you can use this algorithm. You have the system of linear equation. If you multiply R by the pseudo-inverse, this gives the identity matrix, and you multiply the pseudo-inverse by B, this gives the solution 1, 2, 3. You must use a pseudo-inverse. Why? Because A is not square. Sorry. A has 1, 2, 3, 4 line and 1, 2, 3 column. Also, you are not able to inverse this matrix, but with the X value decomposition, you can compute the pseudo-inverse. And when you multiply the pseudo-inverse by A, and you obtain the identity matrix. Alors, you have here the matrice A, the matrice B. You compute U of the X value decomposition. You compute V for the X value decomposition. You take the transpose of the conjugate transpose of U. You take the conjugate transpose of V. Now you compute this value. This value give a diagonal matrix. This value gives a diagonal matrix. Like you compute U and V. This computation gives us a diagonal matrix. This computation gives a diagonal matrix. We transpose A and V. This gives a transpose matrix. It is easy to inverse a diagonal matrix. It is easy to inverse a diagonal matrix because you only inverse the diagonal value coefficient. Then then you can, then you can compute the pseudo-inverse of A with this matrix. Alors, you have the diagonal matrix multiplied by the right by the conjugate transpose of U, and by the right V, by the left V and by the right the U, and this is the pseudo-inverse of A. And now you multiply the pseudo-inverse by B, pseudo-inverse by B, and this gives X, and this gives X. And the result is 1, 2, 3. Alors, I am not able to make the free example because it is too difficult for me, but perhaps you can do this example by yourself with the example of the first example. You have Gauss-Jordan to resolve this function here. You have the QR factorization to resolve this system, and you have the X value decomposition to resolve this system. Thank you.